Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to a new lesson for grade 8 in algebra. The lesson title is The Cube Root of a Rational Number. Here are the learning outcomes of our lesson today. By the end of the lesson, you should be able to define the cube root of a rational number, differentiate between the cube root and the square root of a rational number, solve cubic equations in the set of cube or the set of rational numbers. Let's start by the definition of the cube root of a rational number. The cubic root of the rational number, let's say, if for example it's x, is the number whose cube is equal to x and is denoted by the symbol cubic root of x. Here is the symbol of the cubic root. It's similar to the square root that we took in the previous year, grade 7. Then the cube root of a rational number is the factor that we multiply by itself 3 times to get that number. For example, the cube root of 64 equals 4. Here is the symbol of the cube root, and we write the number below the root, so we read it as the cube root of 64. The cube root of 64 is equal to 4. Why? Because 4 multiply 4 3 times equals 64. Then, when we have a cube root, we search for the number that if we multiply it by itself 3 times, we get the number under the cubic root. Now, let's practice the cubic root in an easy way. What is the cubic root of 1? Let's think together. What is the number if we multiply it by itself 3 times, we get the number 1? Of course, it's 1. Because 1 to the cubic power or to the power 3 equals 1. Next, what is the cubic root of 8? Here we search about a number. If we multiply it by itself 3 times, we get the number 8. Of course, it's 2, because 2 to the third power equals 8. Last, what is the cubic root of the number 125? We surely by now know that it's 5, because 5 to the power 3 equals 125. Here in this table we have the perfect cubes, or the numbers. If we put under the cubic root, it gives us an integer. It's the cubic root of 1 equals 1, the cubic root of 8, as we said, equals 2, the cubic root of 27 equals 3, so on and so forth, until we have the cubic root of 8000 equals 20. After we understood the meaning of the cube root, let's return back to the square root of a rational number. The square root of a rational number is defined as the value which gives the number when it is multiplied by itself 1 time only, and it is denoted by this symbol. So the square root of 1 is still 1, because 1 squared or 1 power 2 equals 1. The square root of 4 equals, yes, exactly 2, because 2 power 2 or 2 squared equals 4. And now we can say that the square root of 25 equals 5, because 5 to the power 2 or 5 squared equals 25. And as we mentioned before that we have numbers named perfect cubes, we also have numbers named perfect squares, that they are the numbers that we put under the square root, we get integers or whole numbers. For example, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 we get 3, the square root of 16 is 4, and so on and so forth until we reach the square root of 100. It gives us 10. Now let's see the main points between the square root and the cube root in this comparison. First, the square root is the opposite of squaring. For example, the square root of 64 equals 8, because 8 squared equals 64, or 8 power 2 equals 64. The cube root is the opposite of cubing. For example, the cubic root of 64 equals 4, because 4 cubed or 4 power 3 equals 64. That is the main difference between the square root and the cube root. Going on to the second point. This is a very, very important point that most of the students forget when solving equations. In equations, the squared unknown has 2 roots. For example, when the example says x power 2 or x squared equals 4. That means that x equal positive or negative root 4. That also means that x equals here positive or negative 2. We do have two roots, the negative 2 and the positive 2 will answer the same example. Let me here clarify this point. If we put here negative 2 to the power 2 or to the second power, it will give us positive 4. And also positive 2, if we squared it, it will give us positive 4. So for every squared unknown, we will have two roots, the positive and the negative root of the same number. Moving on to the cube root. In equations, the cubed unknown has only one root. Here, we do have a unique solution in the solution set. For example, x to the power 3 equals 8. Therefore, x equals the cubic root of 8. Therefore, x equals only positive 2. Negative 2 to the power 3 will give us negative 8, not positive 8. So the solution set here will give us only one solution, which is positive 2. The last point we should know here when comparing between the square root and the cube root of the numbers, that the square root of a negative number is undefined or meaningless. For example, square root of positive 4 equals positive 2, but square root of negative 4 does not equal 2 or negative 2, because square root of negative 4 does not belong to the real numbers or does not belong to the rational numbers, while square root of 4 belong to the real numbers and the rational numbers also. To clarify this point, we don't have any square root of a negative number. Square root of a negative number does not belong to the real numbers and it's undefined or meaningless. If you write down a square root of a negative number in your own calculator, it will give you math error. That means it's undefined or has no meaning. On the other side, the cube root of a negative number is defined. We do have an answer if we have a cubic root of a negative number. For example, the cubic root of positive 8 equals positive 2, while the cubic root of negative 8 equals negative 2. So the two numbers, the cubic root of 8 and the cubic root of negative 8, they both belong to the real numbers. Then the cube root of a negative number is defined, while the square root of a negative number is undefined. This is a very important point for you to remember. Moving on in our comparison between the square root and the cube root. As we said before, that we have numbers that we call the perfect squares. For example, square root of 25 equals 5. 25 is a perfect square. It gives us an exact value or an integer. While 26 is a non-perfect square because it gives us an approximated value. If you put on your calculator square root of 26, it will give you an approximated number or approximated value. So that's why we call 26 is a non-perfect square. On the other hand, we have the perfect cubes. For example, the cubic root of 125 equals 5. Therefore, we say that 125 is a perfect cube because it gives us an exact value, an integer also. While 126 is a non-perfect cube because it gives us an approximated value. We are talking about the same rule here. The perfect squares and the perfect cubes are considering the same rule. We here have numbers that we call the perfect squares, and also we have numbers that we call the non-perfect squares. On the other side, we have numbers that we call the perfect cubes, and we also have numbers that we call the non-perfect cubes. Now let's try to solve the equations related to the cube root. Find the solution set of each of the following equations in Q. X cubed plus 64 equals 0. The first thing we do that we will get rid of this positive 64 by subtracting both sides by 64. After subtracting 64 from both sides, here positive 64 will be cancelled by negative 64 and x cubed will remain as it is, and the other side 0 minus 64 will give us negative 64. So the result of this subtraction will be x cubed equal negative 64. After that, we will take the cube root of both sides. When we take the cube root of x power 3, the remaining answer will be x, and the other side will be the cubic root of negative 64. As we said that the cubic root of negative 64 is negative 4, so the answer of this equation is x equal negative 4. Then the solution set of this equation equals negative 4 because negative 4 belongs to the rational numbers. Another example for solving the cubic equation in the set of Q. 5x minus 2 whole power 3 plus 10 equals 18. The first step is to get rid of this positive 10 by subtracting 10 from both sides. Here we go. Then the positive 10 will be cancelled with negative 10, remaining 5x minus 2 whole power 3 at this side, and on the other side 18 minus 10 equals 8. Here we have a whole bracket to the power 3, not the same like the previous example that we had only x to the power 3. We know that 8 equals 2 power 3. So I can write here 8 as 2 power 3 just to have a third power or a cubic power for both sides. After that, we can take the cubic root of both sides to get rid of the third power. Here, on this side, the cubic root is cancelled with the power 3, remaining 5x minus 2. And on the other side, the cubic root is cancelled with the power 3, remaining the answer is 2. Now we want to get rid of this negative 2 by adding 2 to both sides. Then we will have 5x equals 4, and we want to get rid of 5 by dividing both sides by 5, and the final answer will be x equals 4 over 5. So the answer of the solution set at the end will be 4 over 5 or 4/5. Let's summarize our lesson objectives that we finished today. We defined the cube root of a rational number. We differentiate between the cube root and the square root of a rational number. We solve cubic equations in the set of rational numbers or the set of Q. By the end of the lesson, I thank you all for watching this video and wish you the best of luck, and see you in another videos inshallah. Wassalamu alaikum wa rahmatullahi wa barakatuh.